Hello everyone, welcome to my second video on our course on machine learning. In this video, I'll be covering the basics of machine learning. We'll also be covering its definitions, classifications, its advantages over traditional and conventional coding, and we'll also be dipping into deep learning, which is actually a very vast subject, and we'll delve into it much deeper in my upcoming videos. So now on to the question at hand. What is machine learning? If you guys haven't watched my first video on AI and machine learning, just go over there very quickly and watch it because it'll help you set the fundamentals and basics for machine learning. I'll set the video link in the description. As I said in my previous video, machine learning is a subset of AI. Machine learning can be loosely defined as the science of getting computers to learn and act like humans do. But most importantly, we improve their learning over time in an automated fashion by feeding the data and information in the form of observations and real world interactions. Now, that definition is a bit complicated, but in truth, it actually encapsulates the objective and aim of machine learning. Basically, we get computers to act without explicitly being programmed to. Now, some people may say that all of this is technical jargon and that ML is nothing else but a series of if and else statements. And therefore, I disagree with some people. Blankly stating machine learning as a series of if and else statements is just plain ignorance. It's the equivalent to saying that a computer is just electricity passing through a rock. When in truth, computers are the combination of years of hard work and research, where a deeper understanding of the natural world, complex math, and algorithms work together to create one of the greatest inventions ever. Saying that computers are just rocks forced to think lacks poetic taste. Yes, in essence, machine learning is code, but it involves the careful integration of algorithms, data, and computing power. Machine learning uses statistics to find patterns in massive amounts of data. I mean, really, really massive amounts of data. For example, Google OpenImages dataset has 9 million images, while Facebook recently announced it had a compiled dataset of 3.5 billion images. So, in truth, obtaining the data, cleaning and wrangling it, organizing it into a usable format comprises a large part of machine learning as a profession. Generally speaking, machine learning is broadly categorized into three main categories. They are supervised learning, unsupervised learning, and reinforcement learning. Now, regarding supervised learning, the most striking feature is the data. Supervised learning systems use labeled data. The system studies features annotated to indicate which class a new entry belongs to. For example, images of handwritten figures annotated to indicate which number they correspond to. A supervised learning system could figure out which number is which. However, supervised learning requires massive amounts of labeled data to make predictions that are accurate enough to use. The next one on our list is unsupervised learning. Now, in direct contrast, unsupervised learning does not utilize labeled data, but rather it identifies patterns in data that split the data into classes or clusters. There's also something very interesting called semi-supervised learning, which kind of integrates supervised and unsupervised learning. It's a very interesting topic and deserves its own video. Drop a comment if you want me to cover it later. And finally, we have reinforcement learning, the latest frontier of machine learning. In a reinforcement algorithm, the model learns by trial and error to achieve a clear objective. The model alters its behavior and is rewarded or penalized depending on whether its behavior makes an accurate prediction. Reinforcement learning is very interesting and a very famous example of reinforcement learning is Google's famous AlphaGo. And in fact, AlphaGo was so accurate and efficient, it beat world professional players like Lee Sedol. One of the most modern and advanced frontiers of machine learning is deep learning. Deep learning is like machine learning on steroids. Deep learning uses neural networks, and neural networks work a bit like our brain's neural systems, which is actually a rather decent yet crude analogy. My next video will be an intro into deep learning, so subscribe and hit the bell button for everything AI.
Hasta la vista, baby.